Equally important in the evolution of the Kernel Wars, the battle for controlling surfaces, and ultimately the automotive body industry as well as the nascent Hollywood special effects industry, is the history of surfacing technology. It is not only a tale of mathematical innovation, it is one of brilliant individuals, storied companies, and groundbreaking applications that have shaped everything from cars and aircraft to Hollywood creatures. Behind each curve and smooth surface lies a lineage of ambition and sometimes failure that fueled the digital design revolution. A timeline about surfacing and NURBS. A timeline about surfacing and NURBS. The pioneers of curves, Bézier, de Castelnau, and Verspil. The Peugeot 204, it may not look like much, but it was the first design to use Bézier curves. The Peugeot 204, it may not look like much, but it was the first design to use Bézier curves. Pierre Bézier, an engineer at Renault in the 1960s, developed what we now call Bézier curves and surfaces. They provided designers with a way to manipulate complex shapes intuitively, long before interactive 3D CAD existed. Paul de Castelnau at Citroën simultaneously explored similar curve systems using recursive algorithms. His work laid the mathematical foundation, while Bézier's name became the standard. In the 1970s, Dr. Ken Verspil, then a PhD student at Syracuse University, extended these ideas into NURBS, non-uniform rational B-splines. His insight, with rational weights and local control, NURBS could represent both conic sections and freeform shapes. This was the key that made them invaluable in both engineering and animation. Volkswagen, control data, and the birth of ICEM Surf. In 1983, this VM Mk2 Golf was the first car designed with what became ICEM Surf. In 1983, this VM Mk2 Golf was the first car designed with what became ICEM Surf. Volkswagen, looking to design sleeker cars in the late 1970s, developed VW Surf in partnership with Control Data Systems. This was later commercialized as ICEM Surf, which quickly became the industry standard for classes surfaces, those demanding high aesthetic and manufacturability standards. ICEM Surf's rise was shaped by its success on European luxury vehicles like the VW Golf and Ford Taurus, and later by brands like BMW and Porsche. The software focused on high-end surfacing quality and real-time reflection analysis, which was pivotal for luxury and sports car design. In 2007, Dassault Systems acquired ICEM Surf, integrating it into CATIA V5 as CATIA ICEM Shape Design. The Canadian and Californian contenders, Alias and CDRS. The current version of Autodesk Alias. The current version of Autodesk Alias. In 1983, a Toronto-based team launched Alias/1, which brought real-time NURBS to SGI workstations. Alias soon became essential in industrial design and animation. Used to model everything from the Mazda RX-7 to the dinosaurs in Jurassic Park, Alias was eventually acquired by Autodesk in 2006 and remains a key product in automotive design. Simultaneously, Evans and Sutherland developed CDRS, Conceptual Design and Rendering System, used extensively by Chrysler and other manufacturers. CDRS focused on ergonomic conceptual modeling and later inspired key elements of PTC's early surfacing modules. Stardense dissolution and AVS's legacy. The N8N-like UX of AVS/Express. The N8N-like UX of AVS/Express. Meanwhile in Toronto, Stardent, born from a merger between Ardent and Stellar, created AVS for scientific surface rendering. AVS evolved into AVS/Express, used in molecular and geophysical visualization. It was notable for its integration of visual workflow for creating graphics images. It lives on at avs.com as an innovative data visualization toolkit, but competes with open-source platforms like VTK and ParaView. Beyond the obvious, modern surfacing excellence. The Porsche Taycan, Top Gear. The Porsche Taycan, Top Gear. Some of the finest examples of modern surfacing aren't defined by gimmicks or media hype, but by their mastery of curvature continuity, light reflection, and manufacturability. Lucid Air, designed with Alias and CATIA, its aerodynamic surfaces and subtle detailing reflect true Class A modeling. Rimac Nevra, this Croatian electric hypercar features intricate airflow channels, modeled with a blend of ICEM Surf and VR-based review tools. Porsche Taycan, leveraging Dassault's surfacing tools, it shows advanced continuity and curvature across fenders, doors, and spoilers. These vehicles highlight how modern surfacing software is about more than looks, it's about aerodynamics, manufacturability, and brand language. From NURBS to neural, surfacing in the age of AI. Holographic modeling from neural concept. Holographic modeling from neural concept. The 2020s have brought a new generation of surfacing tools. Neural NURBS, powered by machine learning, suggest optimal control point layouts for a designer's intent. Adaptive mesh refinement now tailors tessellation in real time. Open standards like OpenPBR ensure that materials look consistent across rendering platforms, from Substance 3D to Unreal Engine 6. Even holographic modeling is emerging, with companies like Neural Concept pioneering tools that blend topology optimization, AR/VR visualization, and surface continuity. The frontier now lies not in manual control, but in intelligent delegation. The question has shifted from can we model this? To what's the smartest way to model this, collaboratively, precisely, and in real time?